Hello all, welcome to this session. In this session, we will discuss about how should you prepare for data science interviews and what are the various aspects that you have to focus on. First thing is, needless to say, the data science concepts. And the second thing that you should be well versed with is programming language. And the third thing is the domain knowledge. So as part of programming language, first I wish to speak about this programming language. You need to be either good at R or Python. It is always a plus if you have knowledge of both of these. And the key difference is R is extremely good at statistical stuff. If you want to do any of your machine learning algorithm, etc., on the data that you have with you, right? If you have primary data available with you, you take that data and you perform some statistical analysis or machine learning, forecasting, whatever be it. In those scenarios, R comes in extremely handy if you have one-time data. However, if you have streaming data, when I say streaming data, you have data coming in every day, every hour, every minute, every second, every microsecond. If you have data coming in your way at that pace, then always it is good to learn Python. And you know for a fact that IoT would be generating a lot of data moving forward. Internet of Things, and the researchers say that the number of devices which are interconnected would be 50 billion. So for every person on the planet, there will be approximately 6 to 7 interconnected devices. What would those devices do? These devices will periodically keep sending data, and that data would be streaming data. It's not that you'll wait for 1 hour, you take the data and then analyze the data. No. As in how you keep getting the data, you keep analyzing the data, right? So in those kind of scenarios, Python will work very well. But still, there are a lot of organizations who have data sitting ducks. So they have data residing in their customer relationship management data application or ERP application, or they have their enterprise databases. So data is residing there. It's not streaming basically. In those kind of scenarios, R is extremely handy. So I would say combination of these two will work very well. Okay. And these two are majorly used when you have data which is considered to be more or less small data, right? Or manageable data. What do you mean by big data? If my current application does not support me to perform any operations, then that's the big data issue, right? So if I have, say, 1 million records, and if I have, say, 10,000 columns, and if I want to do some operations, like I want to do a pivot table on that, then my system will obviously hang. My computer will hang. Excel or spreadsheet will tend to crash. That's big data issue. So big data issue doesn't mean handling zettabytes and petabytes of data alone. Any data which cannot be stored and which cannot be processed using your traditional tools such as Excel or any SQL databases is called as big data issue. Okay. So in those kind of scenarios, your R or Python might not work very well, though there are a few packages in R and Python, libraries in Python, which will help you handle big data. It is not very mature. Okay, it is not very mature. So you need to have some other tool also under your belt which will handle big data, and you can think about Spark. But Spark, when it resides on top of Hadoop, will give you multifold result. Okay, but Spark can also be used as a standalone tool basically. So this is in short. Nowadays we have the concept of GPUs, graphical processing units. If you have GPUs installed, R and Python will also be very fast, but it won't be faster than your Spark. But use Spark only when you have big data. For small data or mediocre data, Spark doesn't help. It would be an unnecessary overhead. So that's in short about the tools and the technologies that you should be aware of. At least one programming language, at least knowledge of Spark and Hadoop, and some information of GPUs, graphical processing units. There is something called as CUDA programming there. You need not learn that, at least from majority of the interviews perspective. However, if you get into deep learning, if you get into image processing, video analytics, audio analytics, etc., audio is music included, then probably having knowledge of CUDA also will add a lot. Okay, think about that. You should be having expertise in one of these, R or Python, and then at least some knowledge on Spark or Hadoop. Sorry, and hence we are connecting this drive of how to use Spark as a standalone application, how to use Spark along with Hadoop, and how do you do basic clustering, etc. I mean, the session is currently going on. Tomorrow also we have that session, if you guys are aware of. Okay, anyways, so moving back to the data science concepts. Even before the data science concepts, one more most important thing is the project management methodology. How do you manage this? Just because it is a data science project does not mean you're going to discount the project management aspects. Yeah, so you should be well versed with project management aspects also. So typically what happens in any project, you do the initiation, that is you start the project. How? By signing a formal document. You sign a formal document and then get started on the project. Once the customer approves that you can go ahead with the project, you do some amount of planning and you execute the work based on the plan. Then throughout your execution, you'll also monitor and control the work. So monitoring and controlling will happen. And finally, you close the project. That's the closing part. So these are the 5 phases within traditional project management. You sign a formal document with the customer. You say, all right, customer, I'm getting started on this project now. Okay, then you plan on what has to be accomplished. Then you execute in line with your plan. While you execute, you also monitor and control the work that you're performing. And finally, you formally close the project. These 5 are traditional project management steps. However, in the current world, agile project management is at a rise. Or I would say that at least 99% of the data science projects are being performed in agile methodology. If not, companies have to move to the agile methodology mode. Why? Why is that so? Because when customers give you the business problem, okay, when customers give you a business problem, they are themselves not aware of how data would help them. Majority of the organizations I'm speaking about, they have this theoretical understanding, but practically they are not aware of what are the other business problems which can be solved using data, right? So that is the reason why the moment you have this kind of flickery requirements which keep changing, business problem is not clear, what technology we are going to use, what techniques we are going to use, we are not clear, right? It is very unlike rest of the IT projects. Hence, agile methodology is at the rise. Whenever you have uncertainty in requirements, the techniques or the technology that you're going to use are not very clear. That is when people end up using agile methodology. And if time permits, just have a look at Scrum methodology. It's very simple and straightforward. Majority of the live projects which we are working on, we are implementing Scrum methodology. Of course, it's a tailored or hybrid agile methodology that we're using, not Scrum in its true form, basically. Okay, now once you know what the business problem is from the customer, you need to do your own market research because you're not really sure about whether customer is clear about the business problems that can be solved using data, or is there any other business problem which is more pressing than the business problem which the customer has given you. Customer might say, hey, help me with this aspect, this is my pain area. But after you do your market research, you might find that there are a lot of other business problems which are even more critical than the problem which customer has given to you. Okay, how do I do this market research? Okay, you need to first understand on which industry, which sector, which domain the customer is from. These three are not the same, these three are very different. Financial services insurance is the industry example. Okay, sector could be banking, domain could be risk management. Initially, if you do not have knowledge, you should try to accrue knowledge in the space of domain. Now, these are interchangeably used by people because of lack of knowledge. But now that you know, as part of this session, you know what is the difference between industry, sector, and domain. So don't confuse yourself. All right. So first, try to accrue some knowledge on risk management. Risk management, the basic terminologies, etc. You have to focus on that. Then move to banking. Understand what are the various bankings that are available, etc. Then once you feel that you are comfortable, you have fair bit of knowledge on sector, then move to industry. And it is extremely difficult to become an industry expert. Okay, it will take at least 10 years to gain a lot of experience in industry. Domain, of course, by reading, etc., you will get some knowledge, then move on to sector, then to industry. While you do this market research, also remember another thing which is called as PEST. Understand what is the political situation of the country in which this customer resides and headquartered in. Right? Say you're doing a project for a client in Sweden. You need to understand in which location this customer has a headquarters in, what is the political scenario there, economic scenario, what is a social scenario, and then what is a technological scenario. Pest analysis is what people call this. As part of market research, include this also. Right? So you would be able to cover the regulatory norms, etc. What are the regulatory bodies? Okay, and majority of the aspects should be covered. So you might ask me this question: why do we need to do all these things? Why do I even need a regulatory body? Why do I need to understand the regulatory norms? Regulatory norms are important because imagine you are building a project for a client who is from banking, and you're building a project which is into whether a person will default or not. If you use black box techniques such as neural network or SVM, then of course your accuracy levels might be good. But if someone from the regulatory body comes and audits, then they will ask you these questions on how many people have applied for the loan, and how many for how many applications you have rejected the loan. Then you'll say, hey, out of 100 applications for these 20 customers, we have rejected the loan. Then the next follow-up question would be, why did you reject the loan? You cannot say that I've used a black box technique which has asked me to reject the loan. You should be in a position to explain on what could be the reason on why you have rejected. So you will have various inputs. Say you have used logistic regression. In logistic regression, you'll have the beta values, coefficient values. If any of the coefficient is negatively correlated to a person rejecting the loan, if you get some output in that way, at least that will be a starting point for you to explain on why you have rejected the loan. But in neural network, you would not be in a position to sit down and explain on why you have rejected the loan. Exactly, you cannot pinpoint, right? So that is the reason why regulatory bodies, you need to understand what are the norms, right? So not everyone will let you implement algorithms according to your own whims and fancies and say that this is my algorithm, so don't ask me what happens. Same is the case with anything. Chinese market is a little trickier. The amount of data, or if you're encrypting some data, then European Union has some norms that if you encrypt the data, at least so much amount of key should be given to me, just in case there is some terrorist activity, then I need to read those messages, right? US market has a different norm there. So you need to understand these things. Since you are data analysts, you need to understand what are the regulatory bodies, not just specific to a domain sector or industry, but also pertaining to data in general. When you transport data from US to Europe or from Europe to US, the norms vary because US government is a little okay with sharing the data, but European Union is not that flexible. You need to get to that part. This will hardly take 2 hours or 3 hours if you spend decent amount of time. You need to understand all those aspects, which will strengthen your case when you present yourself in the interviews. Okay, it should not so happen that I'm also one of those regular people who will speak about all the techniques, but I don't know anything else. Frog in the wall. No. Okay, so understand all these aspects. Then what do I do? Say customer has given me the business problem. Then I've also done some research from my perspective as you. Then you go back to the customer saying that, hey customer, I acknowledge your business problem, but during the research, we found a few other business problems which you might want to have a look at. And in majority of the scenarios, based on my experience, we found that customers will start believing you, trusting you, and they will instill a lot of confidence. You will instill a lot of confidence in the customer. And in most cases, they will change their business problem based on your market research. The initial business problem, they will do away with that, and they will eventually say, okay, I feel that your research, and out of this research, this business problem is even more trickier. I think it makes more sense to address that problem first. Okay, so that's the stepping stone. All right. And remember, any data science project is not started to run fancy algorithms, to use fancy terminologies. No, we don't start any data science project for this purpose. We start a data science project to solve a specific business problem. And just because you know data science aspects does not mean you'll end up force fitting data science concepts. A few of the business problems might require simple IT solution, not the data science machine learning prediction part. This should you should be very clear about that. When customer says use predictive modeling, this is my problem, you have to say, hold on, your business problem seems like it can be solved using some other solution, not data science. Okay, people will start respecting you for that. All right. So once this business problem is clear, once customer revises, if need be, the business problem, then actually the customer has to give a document called as project charter. Customer has to give. However, in majority of the scenarios, customers might not know about this, or they might be busy. Hence, they might ask you, say you're joining Cognizant, for example. So they will ask Cognizant to supply the project charter. But that's not right. Nevertheless, even if they give, the project charter will contain high level project requirements, high level project scope, high level project timelines, that is milestones and all that, high level cost, high level risks, and the details of key stakeholders. And the details of key stakeholders would also be available. And this has to be formally signed by the customer. Formally signed by the customer. That's it. Once they sign, you can get started on the project because they have agreed at a high level to the requirements, to the timelines, cost, risks, and you know who the key stakeholders are. Get it signed by the customer, get started. After you start, you have to do something called as data collection. As part of data collection, hey, sorry, are you guys able to hear me now? All right, sorry for the technical glitch. Let's continue. So once you have the project charter which is signed, we need to get started with the data collection. When it comes to data collection, you will have primary primary research, or from the primary sources you can capture the data, or from secondary sources. Of course, in research also there is primary research and secondary research. Primary research means the research that you perform based on surveys that you have conducted, based on experiments, field experiments that you have conducted. Okay, secondary research means You might already be having a lot of data residing with that company or publicly available on internet. Get the data and do some research. So you can get the data either from primary sources or secondary sources. When I say secondary sources, it can be from customer relationship management database or ERP or some kind of Oracle database or MySQL database, right? Something. Primary sources could be the data that you have captured as part of surveys or field experiments. Okay. So once you get the data, and even before you do this part, right, data collection, you should be at a high level clear on what kind of variables might make sense for your analysis. Find out the variables which are applicable for analysis. Okay, you will not go, hunting in the dark basically. So you don't want all the junk variables to come your way. Already there is humongous data that will come your way, right? And analyzing all those variables will be another big headache. Hence, during your market research, also go ahead and do a simple Google search. What are the kind of prediction models that were built in the space of oil and gas, for example? You'll get to know a bunch of those on internet. Just do some reading of all those prediction models which have already been built. Okay, and you will get a fair bit of idea on what variables people are choosing. Okay, as part of market research, that has to come out, that majority of the people who have built the prediction models in the past, majority of the white papers that are available, research articles that are available, say that these are the bunch of inputs that are required, right? So you will specifically try to get those variables to the extent possible from the secondary sources only. However, if you feel that there are important variables which the customer is not capturing, then you will try to do some amount of feature engineering, and you will check on whether you can get those important variables from the existing variables or not. That's feature engineering all about. However, if you if you cannot get those important variables even using feature engineering, that is when you might want to perform some kind of surveys or field experiments to capture those important variables. But it is costly and time consuming. But it is costly and time consuming basically. And whenever you perform surveys, you have to perform surveys using a Likert scale. Okay, so let me write it down rather. So feature engineering, you can do that for various reasons. One reason is to get the important variables which are not directly captured by the customer. Okay, if you have it, well and good. If still you cannot get those important variables, then perform survey. And when you perform survey, to the extent possible, use Likert scale. Why do we use Likert scale? Because it will be giving you numbers 1 to 5 scale. So you will get numbers. You can use those numbers eventually for your prediction purpose. So those numbers that you get would form one column, one variable. So that variable can be used for prediction purpose. Okay. All right. Feature engineering is also used to reduce the number of input variables, right? To come up with the derived metrics and all that. So we will get to that later. But yeah, this is the logical flow. Customer gives you a business problem. However, you go ahead and do your market research. And if you feel there is any other business problem which is even severe or critical to be resolved, then you notify to the customer, and customer might say, okay, I like the business problem that you have brought up on the table, so let's address that, as opposed to the business problem that we have provided. Then you come up with a project charter with high level project requirements, scope, timelines, costs, risks, key stakeholder details. Get it signed by the customer. That means formally you can start on the project. Then, as part of your market research, you should also have identified the most important variables which are applicable for analyzing the data to solve the business problem. Each step that you do, you have to do that with the business problem in mind. Okay. Now, you don't go after the complete data which the customer has. Instead, you'll be very focused in asking those variables which are required for your analysis. First, you have to look out for already existing data, which will be in the secondary sources. If you get all the variables, good, go ahead with your analysis. But if you do not find a few of the variables, then you have to check whether you can use the data in the secondary sources, do some mathematical modifications to get those important variables. That part is called as feature engineering. If despite doing feature engineering, if you cannot get hold of the most important variables, then you have to perform a primary research. Using surveys or field experiments, get the data. When you perform surveys, ensure that you have a Likert scale for the questionnaire so that you get numbers, and numbers can be used for prediction purpose. Okay. I will take your questions towards the end just to ensure that the logical flow is not disturbed. But keep asking your questions, keep posting on the chat. I'll respond only towards the end. Majority of your questions will get resolved by then. Okay. So once you get the data, then you need to perform some amount of data cleansing coupled with feature engineering. And in the due course, you also perform exploratory data analysis. Take each column, understand the definition of that column, right? And then look out for whether you have null values, NA values, right? Some kind of outliers in the data, right? Of course, definition of each variable and the values of that variable. This should be extremely, extremely clear. There is one column which has, say, numbers such as 1, 2, 3, 4. Okay, and 1, 2, 3, 4 are the numbers which are getting repeated in that column. What is the name of that column? What does that mean? What does 1 mean? What does 2 mean? What does 3 and what does 4 mean? So say there is one column called credit rating, for example, just a very hypothetical example, and you have data in that way. Sorry, not 5, again, say 1 to 4, in that way. You need to understand what is the definition of credit rating, how is it calculated, what do we mean by 1, what do we mean by 2, what do we mean by 3, and what do we mean by 4. So all this information should be available. That is what I mean here. Okay. Then you do the data cleansing. If you have NA values, null values, what do? You try to impute the data. As part of imputation, you have mean imputation, you have median imputation, you have mode imputation, Impute is replacing the missing data with some logical data if need be. Okay. Then you have regression imputation, you have KNN imputation, you have hot deck imputation, you have model based imputation. So there are a lot of techniques, right? At least you need to understand what each of these technique does. How does it impute the data? Okay. And for each and every technique that you use, there are only two things that you need to remember. If it is R programming, then what is a R code and what is a corresponding package? For the interviews, important. How to calculate, or what is a formula to do mean imputation? What is a code to do mean imputation? Which package has that function? There won't be too many. There'll be only a handful of those, but by heart, no other escape. Same with Python also. What is a Python code and what is a library or the sub library which has that particular function? Okay. Once the data cleansing part, feature engineering, exploratory data analysis is done, which obviously would consume 60% at least of your project work. Don't underestimate this. People who have no experience in data science will end up implementing the techniques endlessly, but they won't do EDA. That is where in interviews people can easily tease out or understand on who are those people who have practical knowledge and who are those people who do not have practical knowledge. Despite saying this, in the interviews, don't miss this step. Don't feel that interviewers will get excited when you directly speak about the techniques. Don't do that. Techniques eventually you'll speak, but give more attention to this data cleansing and this. Okay. One more thing here, outliers, right? So even before that, as part of exploratory data analysis, you know that you need to do first moment, mean median mode, second moment, variance standard deviation range. You will do your third moment, skewness, fourth moment, kurtosis, right? And as part of each of this, you need to have some key business insights that you can give to the customer for them to readily implement that. Readily, they should be in a position to take an action, right? That is another important aspect of agile methodology. Give the customer some value every week or after the end of each iteration or sprint. Give customers some value, okay? And you can give value, that some value, at the very beginning of the project through your exploratory data analysis. And you also do your graphical representation. Through graphical representation, you'll understand on whether your data are normally distributed or non-normally distributed. You'll understand about outliers, etc. Now, practically in real world, when you have a continuous variable, there might be a lot of outliers. There won't be one or two outliers for you to go sit with your subject matter expert, check with them on why is that an outlier, right? It is practically very difficult. So what really happens is you cut off, you take a cutoff basically, and say it is box plot that you're doing. One thing that people tend to do is they will say that any value greater than some 90 percentile, 90th percentile, remove those, discard. All the values below 10th percentile, discard those, and take the 10 to 90 percentile data and proceed with your analysis. One way. If you have too many outliers on either side, then start treating those as different clusters. Start treating those outliers as a different segment and build another model for that segment. Okay. Now, also in the due course, you have to understand the importance of the variables. Say you have done all these things and you have identified, obviously, even before you got started, you collected only the most important input variable or important variables from the customer. Okay. Now, you also need to assign importance against the variables. How do you identify on what are those most important variables out of 100 variables that the customer gives you? Say you have 100 variables, 100 input variables for building some prediction model. What are the various ways to understand on which are those most important variables? For this, there is something called as information gain, entropy, right? This you will get it from decision tree. Yeah, use it only to get the information about which variable is the most important. Next, you can use lasso regression or you can use ridge regression, or you might want to use your domain knowledge. Okay. So using this, you identify what are the most important variables. Variables that give you the least information, discard those anyways, you don't need it. Okay. This part I would say it is more of business and your data science knowledge until here. Now the actual data science concepts start. Okay. Here, using the business problem itself, one thing should be clear on whether you will use data mining unsupervised learning techniques, or will you use data mining supervised learning techniques, which are nothing but your machine learning concepts, or will you use forecasting or time series? Oh, this part you should be able to understand quickly. But in real world, it is often combination of these that we end up using. Sorry. Okay. In real world, it is often the combination that we use. So let us discuss about unsupervised learning. Clustering. The most basic algorithms are k-means and hierarchical. However, if you have outliers in the data, then you go with k-medians or you go with k-medioids. In this, you have something called as partitioning around medioids for small data sets. You have Clara for large data sets, clustering large applications, clustering large applications. Yeah. We have conducted a few webinars on these. Okay. Now, if you have a very complex data, then you might want to use density based clustering that such as dbscan, optics, etc. So there is one webinar which is planned on 15th Feb or 16th, if I'm not mistaken, on these two, which we are performing, dbscan and optics. Very powerful, because what happens is if you have data like this, assume all the data is like this, and you have data like this, then ideally speaking, this should be one cluster, this internal inside data, and this data which is outside should be another cluster. But your k-means or hierarchical will do it the other way around. And what if you have categorical data? Then you might use k-modes. Hey, k-means has this issue of randomly selecting the clusters for the initialization. What do I do? Go with k-means plus plus. Okay, so if you want access to these clustering techniques on which we have performed a webinar previously, please send an email. Please send an email to inquiry@excelar.com. Please do that immediately. You'll get access to these advanced things. And also there is a webinar which is planned for DB scan and optics. Please attend. Knowledge acquisition, it comes for you for free as part of the webinar. So please don't hesitate. Okay. All right. There might be a few business problems wherein customer might ask you to only perform clustering. Do the segmentation part. That's it. A bank might come to you and say, I want you to take these 100,000 customers or 10 lakh customers that we have, do some clustering, create some segments so that we might devise strategies for each segment and target that segment, right? So you might exclusively come across those kind of problems. Second, I mean, if you have those kind of problems, you end up performing clustering only. In what other scenarios do we use clustering? If you want to build a prediction model, if you want to apply machine learning algorithm, then it really makes sense to first perform clustering and apply your machine learning algorithm on each of those clusters. One more very important thing that you need to bear in mind here. Say you have, okay, 10 lakh customers. You created different clusters. Say you came up with a group of um, 2 lakh customers. You came up with another group of 5 lakh customers, so on and so forth. Right. And then another group of 3,000, sorry, 3 lakh customers. These are the affluent customers. You gave a name to this, which is affluent society. Probably this is your middle class income group. This is your celebrity group, maybe. So in that way, you came up with 3 clusters. If you want to build a prediction model, you can either build a prediction model on all 10 lakh customers. However, the accuracy of the model will not be good. If you create clusters, you are creating groups of homogeneous data. Very, very important. Do not always start working on heterogeneous data, doesn't work. Homogeneous data. And then start applying your machine learning techniques separately on each of these 3. So you'll have 3 different models as opposed to having a single model. And probably logistic regression might give you high accuracy and much better performance on this. Decision tree might give you high accuracy and high performance on this cluster. And maybe neural network might give you better performance on this cluster. So it need not be in this way that you use a single algorithm on all of the 3 clusters. Need not be. Okay, most often this is what will happen. Okay, fine, this is fine. The next thing is dimension reduction. As part of dimension reduction, you have PCA and SVD. This is also factor analysis, close to factor analysis. Otherwise, PCA is close to factor analysis. All right. Why do we do this? One thing, if you have too many columns, in order to reduce the number of columns, you might want to do it. Or you might want to also use this PCA or SVD or some kind of factor analysis to represent data in 2-dimension space, or when you feel that the columns are correlated. you feel that there is correlation, you might end up getting into collinearity or multi-collinearity if multiple variables are correlated. So in those scenarios also, PCA will come in extremely handy. Then you have, of course, association rules, and you also have recommendation engine. In most scenarios, they are using combination of these two. Earlier, association rules was confined to brick and mortar stores, physical retail stores, and recommendation engine was confined to e-commerce. But nowadays, it's a combination which people are using. Okay, it's a combination which people are using. Okay, and then your text mining, natural language processing is very much part of data mining unsupervised learning. Okay, the only difference is when you have unstructured data, you end up using text mining on NL or NLP. If you have structured data, you might want to implement any of these techniques. Of course, there is something else which is network analytics, if I'm not mistaken. Yeah. All right. Now, should you be aware of all these things? Oh, yes. For all of these things, what are the things that I should be aware of? Theoretically, how it works, the R code, and the package, which includes that R code. Python code, if you are also going to showcase that you know Python, then Python code and the library and the sub library in which that function resides. You need to know that. All right. Now, data mining, supervised learning. So all these regression techniques that you know, such as linear regression, logistic regression, multinomial regression, Poisson regression, negative binomial regression, zero inflated Poisson or zero inflated negative binomial, etc. All these are the regression techniques which are very much part of data mining supervised. Okay. When do you use linear regression? When your output variable is continuous. When do you use logistic regression? You use logistic regression when you have a discrete output variable. So let me put it here. When the output is continuous. This is fine. When do you use logistic then? When the output variable is discrete in two categories. And then that's fine. But what if I have greater than two categories? When I say two categories, will a person default or not default? When it comes to multinomial, then output is discrete in greater than two categories, and also categories have no logical sequence. Which color vehicle will a person purchase? Okay, which make of car will a person purchase? Will the person purchase SUV or sedan or hatchback, or what will that person purchase? That's having no logical sequence. Ordinal regression, when output is discrete in greater than two categories and categories have a logical sequence. All this is fine. Then when do you use Poisson? Okay, we use Poisson regression when the output variable is count, number of accidents, number of people entering a shopping mall, etc. Okay, and when mean is equal to variance, that is a condition. When do you use negative binomial? When the output variable is again count, but when variance is greater than mean, which is also called as over display. Under dispersion is not at all a problem. You can still continue with your Poisson or negative binomial. Doesn't matter. That's why we won't discuss about under dispersion. Okay. If you have excessive zeros, basically more zeros, then we end up using zero inflated Poisson or zero inflated negative binomial or hurdle models, etc. Do I need to understand everything? Yes. To what depth? The only depth that you need to understand all these techniques is you understand the code, you understand the package. When I say code, only that one line. Linear regression LM, logistic GLM family equal to binomial. Poisson GLM family equal to Poisson. Right? GLM.NB for negative binomial. That's it. And the corresponding package. That is all that you need to know. Okay. And how do you interpret the coefficient values? If I get beta 1 is equal to 1.23 in Poisson, what does that mean? Etc. Okay. And in logistic regression, the beta values that you get are log of betas, not directly betas. And in Poisson or negative binomial, the output variable is not directly output, it is log of 1. A few quick things that I can suggest. Okay. All right, but I'll build all these models. Say I built any of these regression models. Is there anything else that I need to understand? Oh, yes. You need to always ensure that there is no variance or bias problem. Variance is overfitting. Bias is underfitting. What do you mean? How do I calculate this? Simple. When it comes to continuous output variable, that is linear regression, then you calculate root mean square error for your training data and root mean square error for your test data. Both should be small and close to each other. If both are small and close to each other, that means you are neither suffering from variance nor are you suffering from bias problem. If you are overfitting, then you will have to, of course, remove a few variables. But if you're underfitting, you need to add more variables. That's it. Okay. Root mean square error makes sense when you have output variable which is continuous. But, or MAPE, of course, or mean absolute percentage error, very widely used. Okay. This is fine. All this is fine. But what do I do if I have categorical data in two categories? Then you have something called as confusion matrix. You'll have confusion matrix for training data and confusion matrix for test data. Once again, the same. Both should be small and close to each other. What if I have greater than two categories? Excuse me for my spelling mistakes, but okay. Then you go with cross table. Again, same. The cross table will have accuracy for training data and cross table accuracy for test data. Both should be small and close to each other. Very, very, very important. All right. While you do your regression techniques, one more thing that you need to remember is interaction variables. What does that mean? I'm building a prediction model which includes y, x1, x2 and x3. Good. But you might want to have x1, x2 and x1 multiplied by x2 also and x3. Why do I need to have this? Probably there is some interaction going on between x1 and x2. As part of your exploratory data analysis, this part should become very clear. Maybe when you run the model, or when you try to look at a scatter diagram, maybe there's some interaction going on in that way between x1 and x2, right? So in those kind of scenarios, you might want to use your interaction variable also. Remember, all these things you are doing it on each cluster, or you're doing a cluster. On each cluster you're doing a PCA, and on that you're doing this. Might happen. Recommendation engine, okay, you might want to use dimension reduction and clustering. Text mining also, you might want to do dimension reduction, you might want to do clustering, and then you might want to do something else. So it's always cocktail models that are used basically. Okay, these are all about the regression technique. Then you have lasso regression and ridge regression. Lasso and ridge regression are not used for prediction purpose. They are used for selecting the most important inputs. Lasso and ridge is not at all used for prediction purpose. It is used only for selecting the most important inputs, remember. What do I need to learn from the interview perspective? The R code and the package which is contained in this. If you run all of these things one time, that's good enough. That's the reason why you have assignments. Okay. Then you will have the other machine learning techniques such as decision tree. Then you have random forest. Then you have k nearest neighbor, and most widely used. That is what I'm discussing here. Naive Bayes, neural network, SVM. There are a lot of additional techniques such as gradient boosting, extreme gradient boosting, right? Boosting and bagging, so on and so forth. So here we have something called as ensemble technique. Okay. What is an ensemble technique? Ensemble technique is combination of multiple algorithms. Okay. And within ensemble, there is something called as bagging, boosting, and stacking. What do you mean by bagging? Bagging is simply put, say you have 1,000 data points and you want to run a decision tree model. Either you take all the 1,000 data points, or of course you split it into training and test data. Say you have 700 data points in training, 300 in test. You take these 700 and build a decision tree. Okay, you take these 700 and build a decision tree one time. That's it. Or if you apply a technique called as bagging, it will randomly take 700 data points, build one decision tree. It will randomly take another 700 points, build another decision tree. It will randomly pick another 700 data points, build decision tree 3, so on and so forth. Usually we take odd number, say 3 trials, meaning 3 different decision trees of build. And you will have the accuracies. This has given say 70% accuracy, this 87%, this has given 65%. You simply take average of all these accuracies. Okay, that's bagging. Then what is boosting? Boosting is slightly intelligent. It does the same thing as bagging, but the only thing is it gives more importance to those data points which are incorrectly classified, and it gives more importance to more accurate models. Two steps. Okay. Of course, don't worry, we will do another webinar on ensemble techniques, you'll understand. The third thing is stacking. In bagging and boosting, you can use just one algorithm. You can just use one algorithm and say you're using decision tree. The only thing is you'll do multiple decision trees by taking multiple samples out. Or you can use multiple neural networks by taking multiple data sets, multiple samples, or multiple SVMs. Okay, but you'll use only one of those, only decision tree or only neural network or only SVM in that way. And random forest is one example wherein you use multiple decision trees. And what is stacking? Stacking is you take out of these 1000 data points, you randomly take 700 data points, apply decision tree on that. Randomly take another 700, apply logistic on that. Randomly take another 700 and apply maybe neural network on that. Look at the accuracy of these three, right? And then combine those accuracies. So that's stacking, which is not widely used. Widely used are boosting and bagging, basically. And what is the advantage of ensemble techniques? It gives you high accuracy. And what is the disadvantage? It is slow in performance. So always you cannot argue that accuracy is more important, so I'll use ensemble techniques. Doesn't work, because to run one decision tree, say it takes 1 hour. To run 5 such things, obviously it will take 2 to 3 hours. And if you're logging on to Amazon, you'll not wait for 2 hours for recommendation to happen. So it's always a trade-off, accuracy versus performance. And the most important thing, imbalanced data sets. Always you'll not get a very balanced data set wherein 50% of the output variables are having a category yes, another 50% is having category no. Will a person default yes or no? Okay. Uh, think about loan default. Any bank which gives you data for data analytics is giving you data because that bank exists, meaning the number of people who default is obviously, maybe it would be 10% or 8% or 9%. 90% of them do not default. If you have this kind of data, then it is imbalanced data set. Under such circumstance, if you have imbalanced data set, you cannot randomly sample the data. Random sampling will not work. Then what should I do? There is something called as k-fold sampling technique, so on and so forth. There are a bunch of those. There is SMOT and all that. Hey, how do I learn all these things? Another webinar we have already done. If you need it, drop an email once again to inquiry@xlr.com. Okay, you'll know the process and procedure to get that. Okay. So imbalanced data set, how do you deal with that? That is also very important. You need to understand this aspect also. Okay. I can use any of these techniques for both continuous or discrete output variable. No matter what the output variable is, continuous or discrete, I can use these techniques. So regression techniques is one part. All these machine learning algorithms is another part. Then you have forecasting techniques. If you have time series data, you end up using forecasting techniques. Okay. Say I have used a specific algorithm, it worked very well, wonders, accuracy was good, performance was good. So what do I do? How do I deploy it to the customer? deploy in production. Yeah, how do we do that? Okay, either you can build a mobile application, and why Python is slightly more preferred over R in the current world, because when you want to deploy it in the production, your mobile applications can also be built using Python. And if your machine learning or your data science algorithms are also written in Python, it is very easy to integrate. Or you might want to have some kind of web application, or you want to have our Shiny app, or if the team already has a data science team, the customer already has a data science team, then you'll give the code, ask them to run. But there is also maintenance. You cannot say that I built a model once, it is going to work for you for the rest of your life. That is when we have some kind of maintenance terms. Either based on the data flow or volume of data, increase in data volume, that is how I'll put it. Say you have built a model and the amount of data that the customer has now increased by 5%. Then you will say that, okay, this 5% of data has to be now added to your existing data and a different model has to be built. Or if there is organizational changes, CEO of the company has changed, strategies changed drastically, new set of board of directors have been included, strategies tend to change. If strategies change, the underlying business processes change, and the way data is collected and the kind of data that is collected also change. Okay, so organizational changes, any major business process change, right? Any bill passed in the parliament. Yesterday we had one of our past participant come in here. Let me see, I think Naresh, right? Naresh must be there in this meeting also. He was saying that GST had a huge impact on one of the companies. So they forecasted that their sales would be some 200 crores, but they reached only 130 crores, 70 crores slippage because of GST. Okay, I'm not saying GST is wrong or right, but I'm saying that any such changes is going to have some influence on the business process. It's going to change the entire value chain of the company. Hence, we have to rebuild the model. If Trump says laptops are not allowed for the flights, even in business class, for the flights flying from these countries into US, if that bill is passed by the US, then obviously it will have an impact on the airlines occupancy percentage. So if you already have a forecasting model to forecast the occupancy rate, now you have to tweak it, right? So this is very much part of the final presentation that you give to the customer. This is not a one time solution, I deploy, my job done. No, maintenance is very much part of this, because what usually happens is if you deploy and forget, eventually the performance of the model will decrease, right? Eventually the performance of the model will decrease, and that will actually shoo away the customer from data analytics. They will be scared to use it again. So eventually, until unless you maintain the model, it's not going to give you better results. So these are a few things that you need to be aware of before you plan to attend any interview. And in your resume, you have to clearly mention on what is your project description, right? What is the business problem that you try to solve? What is the business solution that you provided, or that can also include your techniques that you have applied, and what was the final impact for the customer? What was the business impact? It reduced their overhead by 10%. It reduced the number of loan defaulters by 2%. In that way, you have to clearly mention the impact. So these five things should be there for each and every project that you mention. Okay. And for up, assuming that roughly for every year you do two projects, that is how you need to add the number of projects in your resume. All right. Now, I will take a few of the questions that were asked. Okay, let me start here. Which Python programming? Okay, just hold on, friends. I'm just taking your questions. Okay. So which Python programming we have to know? It's Python specific for data science? Yes. I'm not speaking about Python or R from some other programming perspective. Only and only if you can confine your programming knowledge to accomplish data science algorithms, that is good enough. We are not programmers, we are data scientists with some knowledge of programming. Any company expects the freshers to have knowledge of all these three things. Now, not having knowledge on domain is no excuse. You have to start doing research. Just say you are interested in retail, prediction models in retail, recommendation engines built in retail. That is how you need to do some Google search, get to understand what models were built, gain some knowledge on that front. If you're from oil and gas, prediction models in the space of oil and gas, go do some research. You'll get to know what are the various prediction models built in the past, what data analytics has been done in the past. That's a good start. At least 10. That is what I would suggest. At least 10 different prediction models for each domain that you want to get aligned to. Go do some research. Of course, don't stick yourself to only the first page of Google search. Right? Go until 10 pages, search all the links. You'll get some interesting insights. Okay. There are a few more questions. We can use PCA for identifying variables which are important. No, we don't use PCA to understand what are the important input variables. We don't do that. Tableau, yes. Tableau is a data visualization tool which is important, and I was clearly told that, right, so majority of the companies are expecting data visualization piece as well. So that's important. Yeah, you need to know at least at a high level what can be accomplished using Tableau, what uh, analytical capabilities Tableau has apart from its reporting capabilities. Huh. Yes. On maintenance part, it is definitely not like your regular IT wherein they say, hey, add this functionality, add that functionality. It's not like that. It's slightly different in data science. Maintenance mostly includes enhancing the performance of the algorithm. Eventually, you might say, okay, I'll build a model such that if there is new data that will automatically get added, automatically models get built. Okay. So why companies are mixing up big data and data science? Okay. Knowledge of big data is also important. And that is why we provide you with free Hadoop e-learning, right? So if you have regular data, you directly apply your data science techniques. But if you have big data, you need some other intermediate layer before you proceed with your analysis. That's why you need to know the big data piece as well, because IoT, that's going to generate humongous data. Then your regular, small data sets will get vanished very soon. That's the reason big data is important, and that's the reason why we are conducting um, just standalone Spark on top of Hadoop sessions. Yeah, for the interviews, people who completed all these techniques will obviously fare well. So you'll have to just wait and watch. Wait, complete your techniques. Of course, there are still, 200 positions to be filled by a specific company. So you still have time. Yeah. Job salaries depend on your overall experience, not just your data science experience. Now, most of the companies have, or service providers such as Infosys or TCS or Wipro or CTS have all the industries, all the sectors that they cater to. So they do not confine themselves to only life sciences healthcare or only financial services insurance. So no matter which industry or sector or domain that you were aligned to, you will you will be considered. We can tweak the algorithms. Absolutely, we can tweak the algorithms, but given the attributes of that, for example, when it comes to naive Bayes, you can use something called as Laplace. When you use neural network, you can use various activation functions such as sigmoid activation function, tan H, ReLU, leaky ReLU. So there are a lot of tweaks which you can perform. People sometimes go ahead and write their own custom algorithm, but that means you will be in research. You will be a PhD, you take up a different algorithm and tweak it. Usually, we do not see that happening to a great extent. Given the various attributes of an algorithm, we try to change those and see how it's impacting the performance. So, and the best part about Hadoop or Spark is that if you know R, you can write your programs in Spark using R. If you know Python, you can write Python programming in Spark, right? If you know Scala or Java, you can still do that. And which algorithm is best to calculate spending analysis? There is no specific algorithm which fits into the data, or there are no algorithms which are confined to specific industry, sector, or domain. It completely depends on the underlying data alone. So we have a specific course curriculum which we have, which is more or less aligned with most of the job opportunities that you see in the market. So of course, our people might have an edge, is what I feel. So to filling, if there are 200 job opportunities, filling all those 200 job opportunities cannot be done overnight. It will take at least 2 months or so. By then, you all should be done with the trainings.